let's continue with this. So what I need now, I need to estimate costs. And to estimate costs here, we have to add one more column. This is the quantity and unit, and then we need to add unit cost and total cost. And we need to do that for all of those activities here. Then we need to define the unit cost for this, and all of those. So let's start with the information that we have. The information that we have in the inputs, they told us that the company produced asphalt at a cost of $200. So we know that the cost of asphalt is let's say this is the asphalt. We need to put what are the details of this asphalt cost. And the details is the first thing we have the material or asphalt material. And the asphalt material is the quantity is same of the 100 and it is by square meter, and then the unit cost is $200. The total cost here equals to the unit cost multiplied by the quantity. Sorry, we will give this 200. And let's take the subtotal of the all. Other than that, we knew now from the information that there is another similar project done with 90 square meter of asphalt completed at a cost of 125,000. So if we say this is a total, we have another previous project and the previous project was completed with a cost of 125,000. So this is what we call it analogous estimating. Analogous estimating that we talked about in the slides here, that we use data from old project that is similar in the quantity. So we are talking about 90 versus 100. It's not a very big difference. So if this costed 125,000, this probably will cost a little more. The third input that we have is that another project completed with a cost of 500 for each square meter of asphalt. So now here we said we have 200 of the asphalt material and the total of unit cost, subtotal of those. Now it is 200. But this subtotal here, which is the asphalt, so this asphalt subtotal here is 200, was done in a previous project with a 500. That means that at least there is a 300 here more I need to add to the material. So let's assume that I need to asphalt installation, or let's say paving or something like that. The quantity is same, the unit is same. And if we took the same estimation of the previous project, which is 500, that means I have 300 for the paving. or pavement. So in this case, I took the exact same number of the project. Let's assume that that project was done in a time that was previous than this project in many years, maybe 10 years or something like that. Then I need to add the inflation of the materials to the cost here. But since we know that this is 200, we can add the inflation cost here. Maybe we can add 50. The team that will do the asphalt need special training. So that means that we need another indirect cost here. And this indirect cost will be training for asphalt team. And the training will be one-time lump sum and will be at a unit cost of something we don't know. But for maybe if we ask about it, it might cost 10,000 or 1,000. So this training of asphalt team, we will add a note to it. So here, notes. And this is what does it mean, the cost of quality. Sorry, when we take the 500 here, this is what we called it, the parametric estimating. Let's go back to the slides. We talked about analogous estimating, which is comparing project to project. And then we have the parametric estimating, which is comparing units to units from different projects. 3-point estimating, let's give an example for it. Let's say that I held a meeting between experts of backfilling. Then I have 3 people. And here, first one gave me an optimistic estimate. So this is, sorry, the CO. And then I have another one who gave me the pessimistic, sorry, CB. And the third one is the most likely, CM. So in the backfilling one, the first optimistic person told me that it is going to cost $100. Per cubic meter. The pessimistic told me that it is going to cost 250. But the most likely, which is few persons, who talked about a number which is roughly 135. So if I am going to do this 3-point estimating, I have triangular distribution or beta distribution. So let's start with the triangular and beta. As we said, in the triangular, we just take the sum of all of this and we divide them by 3. So as per the triangular distribution, it looks like the average cost is 161. So I can take the 161 here. But if I took the beta distribution, then I need to take the first one plus 4 times of, sorry, the last one plus 4 times of the most likely one and divide all by 6. And now it is giving 148. And as you see, the beta distribution gives you a value that is more closer to the most likely one than the triangular. So it looks like this is the beta distribution giving the the most, or the proper average, or the most probable average. So let's take the 148 as a unit cost here. Next, we will do the road signs. Is there any tool that we can use here? We talk about the cost of quality here. That is the training of the Asphalt team. We say that the training is part of the cost of conformance. We might have something later for rework or something like that, which is the cost of non-conformance. Vendor bid analysis, we will talk about the risks after that, but let's talk about the vendor bid analysis. Let's say that I wanted to hire a team for surveys, so I went to companies that provide survey services, and I told them how much you will take for 2 surveyors for 1 year, and they told me that they need maybe 50,000 per, or let's say 5,000 per month. Okay, then let's see the management crew that I need to work on the project will take 5,000 more. This is from information that I already have. And we can use some of the decision-making techniques here. And then if I need to estimate for this one, I might have some expert meetings with brainstorming or something like that to get the information. And let's assume that we have 1,000 for this. Office preparation, let's assume it will cost 2,000. Other operations will cost 1,000 per month. For the road signs and painting, we can add any numbers here. Let's assume 20 here, or let's assume 200. And then here we have 50. So the total cost that we round up here is 298. We see that it is far more than the project before, which that means that this estimating is, or using the analogous estimating with a previous project is not very accurate. Let's have 2 more columns here for the risks. So let's include a risk tab and our risk reserve. And now here we can study one by one. So for example, if we can look at the risks on each one, and then we can document what is the reason of this risk. We said it is very important to document what is the reason of this. So the backfilling might have a risk of 10%, for example. And here we can say that there is a risk that the materials or the excavated materials or the backfilling may not comply with the quality. And that means I need to do a rework here, and the rework is, we can put it as a reserve, as a 10%, for example. Next, I have asphalt, and the asphalt I can distinguish between a risk here and on the pavement and the material. Since the material is in-house, we can just put 0 here because it is we are building this and we know how much exactly it is going to cost. But because of the pavement, that can be sometimes disrupted by stop of rain, so we can increase that 10% or let's say 15% here. So we can say there is a risk of rain in the execution period. Next, I need road signs. I can add a risk of maybe 5% because the price of signs may increase if I am procuring the signs from outside. The painting, let's say that there is no reserve here. Training for the team, we might have reserve here or no. Let's assume that in the management crew and the survey crew, we have a 10% risk in each one or 20% risk in each one because of the high turnover of the employees. So that means the employees leave the project a lot and they don't stay a lot in the project, and that may affect the work. Mobilization and other operations doesn't have anything. So all of those are called the contingency reserves. We put those reserves, and here is the documentation. We put those reserves because we know that there will be in a small amount of money, and the amount of money we need to add it here. So the amount will be this 10% of the amount here. Then we have here and here and here. So the total of the reserve is 36,900. This is the reserves that we have here in the contingency reserves. So the contingency reserve, as a percentage, we said we can put it or a fixed amount. And then we can have the amount here, and then we have the documentation while we did it. This is included in the cost baseline. We will come to the cost baseline later. And for the management reserves, we can add for the total amount, because this plus this is the cost baseline. We can add for the total amount here at 10%. So I need to add this one plus this one and multiply by 10%. So I would add this as a management reserve. So this 10% is like a general risk or general reserve. I put it for the amounts that I don't know what I am not expecting to have, because those ones I got it from the risk management part, but this one I don't know how much I'm going to face, things that are not expected, so I can put a percentage for it. So let's assume that we have 10%. So this is the part of the management reserve and the contingency reserve. In the next slides, we will try to talk about the cost baseline and the project budget.